Hello everyone, my name is Cassie Chen and I'm pleased to present my final project for CSCIS 89B Introduction to Natural Language Processing. Today I'll walk you through a case study in the use of transformers for NLP tasks titled Corporate Event Detection from Financial News, where we evaluate how well modern transformer models can identify key corporate events from financial news articles, a task with real-world implications in quantitative finance and algorithmic trading. Let me begin by setting the context. In today's financial markets, event-driven trading strategies are increasingly popular. These strategies rely on timely detection of corporate events, such as acquisitions, dividend distributions, or new contract agreements that can influence stock prices. As shown in this example article on the left, the event detection system must process raw financial news, perform contextual analysis, and assign one or more event labels. However, traditional detection systems, often rule-based or reliant on simpler machine learning, struggle with the linguistic complexity and the nuance of financial text. This leads to missed events and false positives, which ultimately undermine trading performance. That's why we turn to transformer models. With their advanced attention mechanisms, models like BERT, Roberta, and Finbert have shown remarkable ability in understanding context and semantics across NLP tasks. In this project, we systematically fine-tuned and compared these three transformer architectures to assess their effectiveness in multi-label corporate event detection from financial news. To conduct this study, we used the EDT dataset from the Trade Event repository on GitHub. This dataset is specifically annotated for corporate event detection and contains financial news articles labeled at the token level with 11 event types, such as acquisition, dividend cut, stock split, plus a non-event O class. We adapted the dataset from token level to article level multi-label format, meaning each article could be tagged with up to 3 event labels. The final dataset consists of 7,770 training articles and 1,948 test articles, providing a robust foundation for model training and evaluation. The dataset is publicly accessible via the Google Drive link shown here. Let me show you what the data looks like. On the left, you see the original token level format, where each word is tagged with an event label or O through pre-processing, including article segmentation, token label extraction, test reconstruction, and label aggregation. We transformed it into a clean article level dataset ready for classification. We also performed exploratory analysis. The average article length is around 470 tokens with a maximum of 512, indicating that many articles use the full model input capacity. The length distributions are consistent between train and test sets, confirming a well-structured split. We selected 3 representative transformer models to compare. The first one is BERT-based, a general-purpose model with 110 million parameters serving as our baseline. The second one is Roberta Large, a larger and more robust variant with 355 million parameters. And the last one is Finbert, a domain-adapted model pre-trained on financial texts. All models were adapted for multi-label classification by replacing their classification heads with a 12-unit output layer 11 events plus O, and sigmoid activation. We prepared the data through an 80-20 train validation split, multi-label, binarization, and tokenization tailored to each model. This approach allows us to directly compare a baseline model, a capacity-enhanced model, and a domain-specialized model under the same experimental framework. Our experiments were run in Google Colab using an NVIDIA A100 GPU for efficiency. We trained each model for 8 epochs with a batch size of 16 using the Adam W optimizer and tailored learning rates. 5 times 10 to the minus 5 for BERT, 2 times 10 to the minus 5 for Roberta and Finbert. A key adaptation for Finbert was setting the parameter ignore mismatch the sizes equals to true to adjust its original 3 class cinnamon head to our 12 class detection task. For evaluation, we employed a multifaceted strategy. The first one is the overall metrics, including subset accuracy, F1 micro, F1 macro, and inference time. The second one is per class classification reports to assess performance for each event type. The last one is sample level accuracy analysis to understand the error patterns and the article level. This comprehensive evaluation helps us move beyond the aggregate scores and really understand how each model behaves. During training, all models converged effectively. BERT-based reached a high micro F1 of over 0.98 by Apple 4 and remained stable. Roberta Large also showed strong learning, though its larger size meant longer training time. Finbert started with a higher loss due to architectural adaptation, but caught up in later epochs, demonstrating its domain-relevant learning capacity. The consistent decline in validation loss across models confirms that they were not overfitting and nor meaningful patterns from the financial text. Now let's look at the test results. BERT-based achieved the highest subset accuracy, 98.77%, meaning almost 99% of articles had all their labels predicted correctly. It also attained the best F1 micro and F1 macro scores, and importantly, it was over 3 times faster than Roberta Large during inference. Surprisingly, Finbert didn't outperform BERT-based, even with its financial pre-training, and Roberta Large, despite its larger capacity, didn't deliver better accuracy. This clearly indicates that bigger or domain-specific doesn't automatically mean better for this task. All models, however, performed exceptionally well, each exceeding 98% accuracy, confirming that transformers are highly suitable for corporate event detection. Drilling down into each event type reveals more nuance. We can group events into 3 performance tiers. The first tier is exceptional performers, like stock split and reverse stock split, were perfectly detected by all models. Acquisition and clinical trial also showed F1 scores above 0.97. The second tier is moderate performers like regular dividend and new contract achieved F1 scores higher than 0.94. The last tier is challenging events like special dividend and guidance increase had lower F1 scores, indicating these are linguistically subtle or context dependent. Across most categories, BERT-based delivered the most balanced performance in terms of precision and recall. Roberta Lodge excelled particularly in acquisition detection, while Finbar sometimes leaned toward high precision and the expense of recall. Beyond per-class metrics, we analyzed errors at the sample or article level. All models achieved very high sample level accuracy, but their error distributions differ meaningfully. Bird-based made the fewest errors, and when they erred, mistakes often involved two mislabels rather than complete failure. Roberta Lodge showed error clustering more pair mistakes within the same article, suggesting it sometimes struggled with complex or ambiguous news items. Finbar had the highest number of imperfect samples, but many retained a relatively high accuracy, meaning its errors were often less severe. This granular view helps us understand not just how much each model errs, but also how it errs, which is crucial for real-world deployment and future improvements. So what are the main takeaways from this study? First and foremost, bird-based emerged as the optimal model for this task. It delivered the highest accuracy, fastest inference, and most robust error profile, challenging the assumption that bigger or domain-adapted models are always superior. Second, we observed distinct error patterns. Bird-based errors tend to be paired. Roberta's clustering articles and Finbar's are more frequent but milder. Third, task alignment matters. Finbar's financial pre-training didn't fully transfer to event detection, reminding us that domain adaptation is not a silver bullet. The pre-training objective must align with the downstream task. For practical deployment, we recommend the bird-based for its balance of performance, speed, and stability. Future work could focus on reducing error clustering in Roberta, improving Finbar's fine-tuning alignment, or even exploring ensemble methods that leverage the complementary strengths of these models. That brings me to the end of my presentation. To summarize, we conducted a comprehensive comparison of Burr, Roberta, and Finbar for multi-label corporate event detections from financial news, with Burr-based proving most effective overall. Thank you for your listening.